This is Geometry A, Unit 5 on Transformations, Lesson 3 on Rotations. We've looked at translations, slides. We've looked at reflections, flips. Now we're going to look at rotations, or spins. Okay, so let's start with a graph system here. So the idea is we're going to take a picture, a shape, and we're going to put a pin, a push pin if you will, in the graph at the origin. Okay, so let's put the origin right here. Draw the y-axis. Y-axis goes up and down. X-axis goes left and right. Positives go right, negatives go left. Y positives go up, negatives go down. And I'm going to start with a triangle here. I'm going to put point A right here, point B right here, and point C right here. Okay, let's do this here. Let's put this further out. A, B, C. Coordinates of A are -1, 3. Coordinates of B are 4, 6. And the coordinates of C are 2, 4, 6, 2. Okay, and let's connect the points so we can clearly see the shape of the triangle. Okay. What I'm going to start by doing is I'm going to make a rotation about the origin. So I'm going to put the center of rotation at 0, 0, at the intersection of the x and the y axes. So we call that the origin, where the lines, where the x-axis and the y-axis cross. Okay, so let's create a new layer here because I don't want to change this screen here. So I'm going to take a screenshot, and we're going to paste it over here. So screenshot, actually not a screenshot. Let's just do a capture, video capture. And let's make sure we're on this right here. Okay, and let's go out to here. And the key here to make this work on the computer is to make sure that we have a perfectly square region. I think that does it here. All right, copy and paste. Okay, so now I should be able, there we go. I can grab it and spin it. Okay, so that almost worked perfectly. I'm going to readjust here. So that's a rotation if you will, of 90 degrees. Rotation of 90 degrees. Okay? And so this now is A prime, B prime, and C prime. You remember the tick marks mean image, so A, B, C is the image, A prime, B prime, C prime is the object. Let's look at what happened to the coordinates of each point where we put them here. So A prime seems to be at 3, 1. B prime seems to be at 2, 4, 6, 2, 4. So 6, -4. C prime seems to be at 2, -2, 4, 6. 2, -6. Now look carefully at these coordinates. Do you see a pattern? What seems to have happened? -1, 3 became 3, 1. 4, 6 became 6, -4. 6, 2 became 2, -6. So I hope you notice that the x and the y seem to have switched. but also that what became the y value changed signs, right? Changed signs. So here's the general rule for a 90 degree clockwise rotation. Now, by the way, something worth bringing up. I did a clockwise rotation first. That actually is a negative rotation. Negative rotation. Counterclockwise rotations are considered positive. In mathematics, we consider a counterclockwise rotation to be a positive. So if you're given in a problem, rotate this 90 degrees, the default is counterclockwise. Lefty-loosey if you want to use the term from mechanics. If you want to loosen the bolt, you turn it to the left. If you want to tighten the bolt, you turn it to the right, unless it's reverse threaded, which is very rare. All right, so here we go. 90 degrees clockwise rotation. Let's see if we can come up with a rule. XY is going to become, switch the X and the Y, so YX, but change the sign on the new Y coordinate. Okay, so that is the rule for a clockwise or a negative rotation of 90 degrees. All right, let's go ahead and hide that here, and let's see what happens when we do a counterclockwise rotation, a positive rotation. Okay, so let's do that here. So let's grab a, oh, not a screenshot. We're just going to grab a copy here. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure to grab a nice square region here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay. And now, copy and paste. Center it here a little bit. And now I'm going to spin it counterclockwise. So I'm going to rotate it 90 degrees counterclockwise. Oh, I didn't center it right. I was off by a grid square, but that's okay. I can adjust. Okay, so we're going to rotate 90 degrees and move it over here. Okay, so that the axes line up. There we go. All right, so here we have a 90 degrees positive or clockwise rotation in which our image A prime, B prime, C prime is over here. Okay, and let's see what happened. A prime, B prime, C prime. A seems to be -3, -1. B seems to be -2, 4, 6, and 4, -6, 4. C seems to be -2 and 2, 4, 6, -2, 6. Now look at those numbers, and before I tell you, see if you can figure out what happened. Okay, so -1, 3 became -3, -1. 4, -6 became -6, 4. 6, 2 became -2, 6. So you'll notice again the switching going on between the x and the y, but this time what became the x term, switch signs, became negative. So the rule for a counterclockwise 90 degree rotation, okay, or a positive rotation, is xy becomes yx, but the y that became the x, the first coordinate, is now negative, has changed signs. If it was negative, it's positive. It's positive, it's now negative. All right, so that's how you do a 90 degree counterclockwise rotation. There is one more rotation we want to do, and I'm going to squeeze this in. I'll try to be efficient about it here. Okay, so let's go ahead and hide this layer here. All right, and let's go back here. And this time I want to do a 180 degree rotation about the origin. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay, copy and paste. Okay, and we've got it just about right here. Recenter it a little bit. Okay, now I'm going to rotate it 180 degrees. Now, since I'm going 180 degrees, I could go righty-tighty, lefty-loosey. I'm going to go counterclockwise since that's the positive direction, but it really doesn't matter. The end result of spinning 180 degrees is the same no matter which direction you go. And we've got it a little bit off-center, but not too bad. All right, come on, there. All right, and let's recenter that here a little bit. Okay, and so the image, you'll notice, is now down here around the opposite side. So A prime, B prime, C prime. Okay, and let's take a look at what happened to those. A prime, B prime, C prime. The image of ABC. A seems to be 1, -3. B seems to be -2, -4, -2, 4, 6, -4, -6. C prime seems to be 2, 4, 6, -6, -2. Okay, look carefully at what happened to each of these coordinates and see if you can figure out what the rule is. Okay, this is a 180 degree rotation, which is also something called point symmetry or point reflection, a point reflection, or a reflection across the origin. And I'll show you why that is. Okay, but here it is. So x, y, you'll notice, you hopefully noticed that the coordinates switched. So the x moved to the right and the y will move to the left, so it's yx, but also that both signs changed. So in a 90 degree rotation, the coordinates switch, but only one of them changes signs. In a 180 degree rotation, the coordinates switch and they change signs completely. Both of them change signs. Now the point symmetry part here is this. If I draw a line connecting every point with its image, so if I connect every point of the object with the corresponding point of the image, okay, you'll notice something here kind of interesting. There's A to A prime. Here's B to B prime. And here's C to C prime. Okay, and hopefully what you notice is that all of these lines go through the origin. That's the point we spun around, right? So they have point symmetry, or it's a point reflection with this point. If I go the opposite side of the origin from C, I get C prime. If I go the opposite side of the origin from B, I get B prime. If I go the opposite side of the origin from A, I get A prime. All right, so that's rotation for you.